In early April 2025, the APRF investigated the alleged haunting of Knowlton Church and Earthworks. At the end of the investigation, we committed to a longer-term study of infrasound at the site to see if our theory regarding the possible cause of people's experiences there would hold up. Before we go any further, let's have a quick recap of the history of the site, the alleged phenomena reported there, and what we think could be responsible, at least in part.
That's fine. How many of us have ever messed about doing something silly like this? But have you ever wondered what produces the sound? Well, it's a scientific phenomenon known as Helmholtz Resonance, and it's where the air flowing over the top of the bottle briefly compresses the air inside of the bottle. Now the air inside of the bottle, being springy, pushes back up against the air flowing over the top. This produces an oscillation, and the rate of oscillation determines the frequency of the sound we hear. Now, what if the tower here at Knowlton Church is also acting like a resonating chamber, but instead of producing an audible frequency, it's producing something below 20 Hertz, the point at which humans are able to hear. Now at 18.98 Hertz, the human eyeball will vibrate, and the rod cells towards the outer and back part of the eye are stimulated into thinking that we're seeing something that actually isn't there. Now, using complex monitoring equipment, we're hopefully going to find out what frequencies are prominent here, and we'll bring you the results at the end of the video.
We'll shortly bring you the full results from our repeated infrasound study at Knowlton Church, since the APRF's original investigation there 8 months ago. First, let's look at some of the terminology we'll be using.
Sound propagates through mediums such as gases, liquids and solids in the form of waves. A vibrating object creates a disturbance that pushes on the particles around it, forcing them closer together and creating a compression. As the particles return to their original position, they spread out and create an area of lower pressure called a rarefaction. The round trip from normal pressure to maximum compression to maximum rarefaction and back to normal equilibrium pressure constitutes what we call one complete cycle of a sound wave. The number of cycles that occur each second determines the frequency of a sound wave, whose standard unit of measurement is the hertz. Therefore, one cycle of a sound wave per second equates to a frequency of 1 hertz. 2 complete sound waves per second equates to a frequency of 2 hertz, and so on and so forth. The frequency of a sound wave, as seen in this displacement time graph, is measured along the horizontal or x-axis and represents the status of the wave at a given point in time. The power of the sound wave, more commonly known as its volume, is measured along the vertical or y-axis. The distance from its equilibrium point to any given point on the wave above it that demonstrates the compressional part of the wave is known as the amplitude. It has a positive value. Additionally, the distance from the equilibrium point to any point on the wave's trough demonstrating rarefaction is also the amplitude. It has a negative value. Therefore, the total vertical distance between a peak and its corresponding trough is twice that sound wave's amplitude. The unit for measuring sound volume or intensity is the decibel, which is a logarithmic scale related to the sound pressure, amplitude, and energy. The aforementioned properties of sound waves also apply to infrasonic waves, that is, waves below the frequency of 20 Hz, the point at which humans are able to hear. Let's now take a look at the results of our extended infrasound study at Knowlton Church, which we conducted during the 8 months following our original investigation there. In order that we may apply what we have just illustrated to our results, we'll start by looking at a 20-minute sample of the actual infrasound readings taken during our investigation on the 5th of April 2025 at Knowlton Church. Here, along the bottom of the spectrogram, we can see the frequency values from 0.5 Hz to 20 Hz moving from left to right. Humans are able to hear from around 20 Hz to 20,000 Hz, also known as 20 kHz. Therefore, all of the frequencies below 20 Hz shown on this spectrogram are generally inaudible to humans. The vertical axis shows the number of counts per frequency, that is, the number of times a specific frequency is registered during the selected time period. We have selected 20 minutes as a time period across all of our spectrograms in this exercise, and so all of our charts are consequently directly relative to one another in terms of time and frequencies versus counts. Our monitor is an Infotech Infra 20 infrasound recorder and takes measurements or counts at a rate of 50 per second. It should be noted that our spectrograms do not measure the strength or amplitude of each frequency, only the number of counts, indicating the presence of that particular frequency every 1/50th of a second. We will talk more about the amplitudes of our measurements in a moment, but let's now look at what we captured on each return visit to the ruins of Knowlton Church. Many of you will have noticed distinct differences between some of the readings taken within minutes of each other and for the same period of time, and wondered why this is. Well, the primary factor is the sheer randomness of the wind's behaviour, which, although blowing from a singular direction, contains indeterminate and sporadic gusts, generating a secondary factor known as vortex shedding when the wind encounters a structure. The humidity of the air is also a consideration, and the net result of the aforementioned, often combined, contributes to the remaining two factors we will talk about, namely constructive and destructive interference. For ease of simplicity, we will concentrate on these four factors as they best illustrate the differences between our results, both inside and outside of the church on any given occasion. Vortex shedding is a phenomenon where wind, in this case, passes the surfaces and edges of the church tower and ruins, causing separate vortices to form and detach from the structure of the church. This creates a fluctuating force perpendicular to the wind direction. Vortex shedding creates new sound frequencies in the form of tonal noise known as aeolian tones. These sounds occur at a specific predictable frequency determined by the flow conditions and the size, angles and surface of the church structure. Whilst we could not ascertain any obvious direct links between humidity levels taken at the time of our infrasound measurements and any associated proportional relationship increase in infrasonic levels obtained, there is strong evidence to prove that infrasonic sound waves travel further in more humid air. This would then facilitate the possibility of infrasound created elsewhere being recorded at Knowlton Church. The speed of sound increases more in humid air because water vapour is less dense than other gases in the air. However, this effect is minor compared to humidity's impact on the absorption of sound wave energy. This is due to the fact that attenuation or loss of sound energy in water increases with frequency. Higher frequency sounds are absorbed and scattered more quickly than lower frequency sounds. Humpback whales, along with other baleen whales such as the blue and fin, communicate with calls as low as 10 to 39 Hz. These infrasonic calls are able to be received hundreds of miles away. When the crests of one wave align with the crests of another and the troughs align with the troughs, we say that the waves are in phase with one another, and this has an amplification effect. The amplitude of the new combined wave is the sum of the constituent individual amplitudes, regardless of whether they are the same or different, as long as they are in phase. Therefore, if the constituent waves each have an amplitude of 3 units, the resultant amplitude would be 6 units. This may go some way towards explaining why certain infrasonic frequency counts are higher inside of the church on occasion. Infrasonic waves with an amplitude too weak to register on the infrasound monitor become more powerful through the process of constructive interference, and a resulting wave is then strong enough to register a count on our monitor. This is hardly surprising when we consider the vast number of opportunities sound waves have to reflect off the many angular, flat and irregularly shaped surfaces and walls of the church. When the peaks of one wave align with the troughs of another, we say the sound waves are out of phase. This results in a quieter sound, or even a complete cancellation of the sound wave's amplitudes altogether. In this situation, less infrasound may be present inside of the church tower than outside of it, as infrasonic frequencies are cancelled out due to sound waves reflecting off of the various surfaces of the church and becoming out of phase with waves of the same amplitude. If the cancelling wave is larger, it won't achieve total silence, but will instead reduce the overall sound or create partial cancellation in some spots and louder spots elsewhere. This is the reason why we started to take measurements outside of as well as inside the tower to see if the ruins of the church change sound frequencies, and indeed, as with most other buildings and structures, it does.
Having now reviewed the overall situation and, to the best of our knowledge, applied as many applicable principles as possible to the task at hand, we feel we can comfortably state one key finding to our research at Knowlton Church. Our initial hypothesis regarding a single prominent infrasonic frequency generated by Helmholtz Resonance has failed to be proven. However, on occasions, and owing to constructive interference, more infrasonic frequencies were recorded inside of the church tower than outside of it, sometimes markedly so, and especially at the extremely low frequency range of the infrasonic sound spectrum. There does not appear to be any correlation between atmospheric conditions and our results other than more infrasonic frequency counts being recorded both inside and outside of the church tower when conditions were more windy.
The significant frequency of 18.98 Hz we were looking for might not have shown as a dominant significant frequency on our charts, but if future scientific research proves a correlation between prolonged exposure to a range of infrasonic frequencies and perceived paranormal experiences, we will at least have a set of records to review and re-evaluate. In closing, we would like to urge anyone and everyone undertaking a ghost hunt or paranormal investigation to give special consideration to both the location they are investigating and the potential effect the environment may be having on it, and indeed vice versa. It may well transpire that the location itself is contributing towards the construction of perfectly accountable phenomena once a degree of critical thinking, common sense and logic are applied. We should do this always and question absolutely everything before ever reaching for the word ghost.